Hello. So I put this talk together, and I got it all ready, and I had it down, and then I went on vacation for 8 days. And so let's see how this goes coming back, because I got back from vacation. 16 hours later, I jumped on a flight to come here. So let's hope I remember everything through this. Let's see how it goes. So first, for those of you who don't know me, this is just a quick intro slide. You might recognize me from some of these things. I won't talk through it too much, but I work on Helm and charts and SIG apps and things of that nature. You might recognize some of these logos or some of that if you're looking to identify who I am and what I've been doing. So when I talk about the community charts, I'm talking about the charts repo. We've talked a lot about today about charts that are company charts or your own workflow for your own charts. Well, one of the things that we have here is a community set of charts. The stable portion of those you can get access to in Helm right out of the gate. There's also Incubator that you can add. And so that's really what I'm going to talk about here today. The one image is the GitHub page for the charts. And then the other image is Kubeapps from the folks at Bitnami, which lets you visualize and see this and have dashboards and do things like that with those stable and incubator charts. Now, before I get started, I actually want to give a shout out to Vic, wherever Vic is, because Vic's the one who got testing going for all of these charts things, for all these public charts. And you'll see there's two pictures here. One is like business Vic, and the other one is Vic, I'm guessing in his natural environment. And these are the two pictures I found for him. So if you see him, take a minute and thank him for getting this charts testing going and all the stuff that he's done. Hi, Vic. Thank you. But Vic just hasn't done it alone. These are all the different people who've contributed to the testing over time. So if you see one of them, thank them for their contributions. These are the folks who've helped make this testing that I'm going to talk about possible. And so give them a thanks. And so let's dive in. Now, one of the things I'm going to talk about here is the lessons learned. So I'm going to talk about how the testing works, the tools we use and things like that, how it's changed over time, and why. Because I think the why is a really important thing to learn along the way. And so let's start by looking at the life of a pull request to the charts repo. And this is the way it was about 6 months ago. A pull request would be created, and you'd get CLA checking because you've got legal stuff. And so you're just going to see that everywhere here, and it's because of lawyers. And then the next thing we would have is end-to-end testing. This is where we would just test all of the things. This is, the pull request would come in for a new chart, a change to a chart in this repo, and it would just get tested. And this is kind of what the testing looked like. For each chart, you'd have the PR come in, and we'd lint it, and if it failed, we'd tell you what was going on, and then you'd have the chart installed and tested. We'd actually install it into a Kubernetes cluster. This cluster runs in GKE, and then we would run Helm tests, some of the stuff that was talked about earlier, where you can have tests along with the chart, and so when it's actually running as a release, we test, make sure it's up and going. Otherwise, we just generally test, make sure the images pull, the chart works, the API objects all actually function, and don't throw an error. And so if all of that passes, you're good to go, and it would pass. But there's a big problem with that. Anybody ever experienced this? The note that says you need OK to test before the test run, right? This is a pretty common thing on the charts repo, right? Because OK to test. So the way testing works with the Kubernetes infrastructure is that if you're a member of the org, your tests run right away. If you're not a member of the Kubernetes org, you have to wait for a member to do OK to test on it. And the reason for this is we run our own Kubernetes clusters. We have a lot of our own testing infrastructure. And we have a lot of long-running tests, which means you don't have timeouts and things like that you get with Travis and some of these others. And so we'll have stuff that could just run for hours at a time to test Kubernetes. And so what if somebody came along and just submitted a pull request to do Bitcoin mining or something like that, and we didn't have any checks and gates in place? Well, that could cause a lot of problems. And so this is a security thing, but it means you have to be a member of the org or get OK to test before you would get any of that feedback. Well, when you look at our contributors, a whole lot of them are not members of the org, right? Of the top 100, it's 74 of them are not members of the org. And so we run into a lot of people who would run into this OK to test. And they might have to wait hours or days to get any feedback from CI on their pull request, something we're not used to. Now, when you really think about it, we've also had, since KubeCon, as far as contributors to the charts repo, we've had better than 30% growth in people who are contributing. And so there's a lot of people contributing to charts, and there's growth here, and they're not maintainers. And so we introduced an intermediate step. Circle CI to give immediate feedback, or almost. It takes a minute or two, and we can give feedback immediately to everybody without having to go through the OK to test. Because the lesson was, we've got a lot of people coming, and there's a lot of little things, and a lot of times things break, and if they've got to wait days, it throws them out of the loop of expectation. So let's give people immediate feedback and not make them wait. And so we introduced that step. And then the E2E testing was more of, let's actually run that chart later. So the first thing we did was we actually collected what were the things that we wanted to try to do static analysis on, analysis where we're not running it. And so we went to folks like Reinhard and some of the others and said, what are those lessons learned? Let's get them, let's document them, and then let's automate them. So that way we can have automated testing of as much stuff and only put human eyes on the things that are odd, are quirky, are changing. Let's automate it, right? Let's automate our reviews. And so this was the first set we came up with, right? We can do a dep build to look at all the dependencies of a chart and make sure it actually builds. We can lint it and actually, make sure it passes linting. We can do YAML linting to make sure, all the indentation's right. You have the new line at the end of a file, things like that. You follow a certain formatting. We can verify you've incremented a version. In the charts repo, we want everything to be immutable. We deal with immutable infrastructure. We should have immutable versions. And so we want to make sure and enforce that the version is incremented and actually check that the notes template and a README file exist. And we can make sure these are here. These are really common things. And so we said, we're going to automate these things through Circle. And the first thing was we did YAML linting, and we use a Python package that lets you do it with a config file. You can actually go see it in our repository in the test directory. We use a YAML lint, and we check just the chart and the values file, because those are the only actual YAML files in a chart right now. Everything else is a template, and a lot of times those will fail linting. And so we check these two files, make sure they're in place. The next thing we do is, along with some bash scripts, we use a tool that'll let us YQ, which will let us do YAML querying, so we can look at the YAML files and pull values out and do manipulations on them. And then we use a tool called vert, which uses the same semver comparison tool that Helm does to let you do version comparison. And then we've got a little logic, right? Here's the logic for our shell script and our version checking that we do. And it says, is it new? Okay. You shouldn't have a version bump. If not, we actually check out the master version of that chart, and we grab the version out of it, and we grab the version out of the PR, and we say, is it newer? If it's not, we fail. If it is newer, it's fine. We actually do a little logic in a shell script to make sure that if it's a newer pre-release and things like that, that all works, and we make sure that whatever it is a valid semantic version increase. That's today. The next thing we actually want to get into is we want to go and say, we can go a step further. We've got Helm template. We want to actually generate and validate the Kubernetes objects coming out of this for every version we support. And so we want to be able to use Helm template, pass in the Kubernetes version, generate the artifacts that it would do for those, and then we want to go ahead and validate, do those pass, because this will give us an extra level of checking. And so that's the next thing we want to get into. And there's a tool for that. It's called kubval. And kubval will actually, it calls out to get the JSON schemas for all these different versions, and then it can validate, do your Kubernetes objects pass? And so this is the next thing we want to do. We want to generate those, validate them as part of the static analysis, and so people can have immediate feedback. You've done this wrong, you've tweaked this wrong, this output is bad. By having this in static analysis and giving it right away, we give immediate feedback that is useful and actionable in the short term. So back to the life of a pull request. Let's look at how we do end-to-end testing. End-to-end testing actually works through the Kubernetes CI system rather than Circle CI. And it works with, we use merge automation. The merge automation, if you've worked on Kubernetes, is you can do things like /approve, /looks good to me, and a merge bot, once it's ready to go, will go ahead and do the merging. Kubernetes needs this for its massive scale of pull requests coming in and merging that needs to happen. We've adopted it on the charts repo so we can work with owners, files, and deeper permission systems. But it means the end-to-end testing actually runs at 2 different times. When you're an org member or you get OK to test, or when something is ready to merge. When it's ready to merge, the Kubernetes CI system, before it merges it, the merge bot, will actually run these tests again. And so if something's changed, maybe it passed the version increment when somebody submitted the pull request, some other changes came in along the way, and the version isn't newer anymore, it'll actually check it again here. And that gets us into checking. And maybe this version merged with this other new version also caused something else to break and it doesn't run anymore. We'll check it here to make sure that right before we merge it, everything still works. And so this is kind of what the pull request would look like. You actually see these are the 4 different checks on a pull request to the charts repo. And you can see that when tied, which is the merge automation for this, goes green, it actually goes and reruns the test here, which is in yellow because it's running right now, or it's queued to run. And once that turns green, the merge automation will come in and say, they're all green, we'll go and merge. All right, so this is what, about 3 months ago, what the end-to-end testing system looked like, right? It would actually check, is it a newer version, and fail. If not, it would build and fetch any dependencies. It would install it into a live cluster, and then does it pass Helm test? Yes or no? Yes, success. No, failure. Just clean up, right? But that left us with one question, something that kept happening. Why did the chart fail to run or pass tests? How do you know what happened? What if you were running it locally and it worked just fine? What if you were running it in your own GKE cluster or in Amazon or Azure or wherever, and it ran fine, and yet in our CI system, it's failing? How do you know? So we introduced another step here, and I want to say it was Adnan who came up with the idea to do it this way. You'll see on the no path here, where does Helm test pass, we now list the logs for all the pods and any other data we can when things fail. And so we will dig in and provide all this just massive amount of data into the logs so you can try to diagnose what went wrong. And our script for this is actually pretty simple. To get all the logs, everything's in a separate namespace for the pull request when it's tested. And so we'll go ahead and we'll just say, in that namespace, give me all the pods. And then in the pods, give me all the containers. And then we'll list over each of the containers for each pod and list out the logs. Because if you've got more than one container per pod, you'll fail to just try to get the logs in the pods. And so we go that extra step and break it down and spell it out. This is the script we use here. These slides will be online if anybody wants to copy this later. But this is how we look at getting all the logs to provide that verbose feedback. And it turns out this has helped us solve a whole bunch of problems along the way. But we do more testing than just pull requests, because there's a lot more going on than just pull requests. You think the day in and day out is pull requests, but this is part of the Kubernetes project, and what's going on with Kubernetes master? And so one of the things that we do in addition to that is we test the latest Kubernetes tip against some charts. If you actually go look in the test info repo, you'll see we have a job that executes every hour that will grab charts and run it against the tip of master on Kubernetes to say, is stuff still working? Did something break? What's going on? Because we want to catch if there's a change to Kubernetes itself that causes things to start breaking across the board. We want to know early when things fail so we can go fix Helm or fix the charts or go fix something upstream if there's a problem there that's causing issues. We want to keep an eye on compatibility. Right now, these are the charts that are under test. They come out of the charts repo. And several of them actually have different reasons for being under test. But you'll see this is the change. And this list changes. Sometimes we add some, sometimes we remove some because there have been issues with the charts. We'll probably be doing some of that again here shortly to just revise that list because, as you'll see in a minute, there are some problems. So are they passing? The answer, before I went on vacation anyway, was no. Jenkins started failing. In fact, this was one of the lessons learned. We didn't even realize things started failing in this testing scenario because we had them all green and then something went red. But there's actually a place where you can go see how different tests are running or failing. And in this case, you can actually see which one it is. So we know it's Jenkins, and we know it's from the charts test. And then there's all the other ones that are passing against head, every hour, always running. And so, but part of this is we said, well, when did things fail? And so we went back and we looked and said, when were things failing? And when did it start failing consistently? And it's kind of blurry, so you can't read it probably, but we learned that this was actually a few weeks ago now, that things started failing. And so we can look at when it was failing, what change happened to the charts repo at that time that would cause it to start failing against tip, because it's not failing against the clusters we're running against, just the tip of master. And so what happened? And then we can go diagnose what happened. It did end up leaving us with an open question that is one of the next things we're going to go figure out is, how do you get notified when tests start failing, right? If I use Circle or something like this, I get an email when things start failing. When this started failing, I didn't get notified, and it was just because we went and looked, because it's not one of those tests. And so that's one of the lessons that we learned is we got to figure out how to do notifications so we know when it's failing so we can go catch and react more quickly than expecting us to pull every so often. So this is one of the next things up on our agenda to take a look at with the charts testing. But I think I talked quick. And does anybody have any questions about this?
Can you give us any stats about the rate of passing and failing tests for typical charts? Do you collect those stats?
We don't. Most of the charts, they're green most of the time. I don't know that we actually have statistics on how often charts are failing or passing. A lot of this is just like for the pull request workflow, a fair number of them fail because, people who are new, because we have lots of new contributors, don't know to increment versions and things like that. So it'll fail a lot of time on the static analysis because they're those little things they just don't know about how we do things, even though they're documented. How many people, when they come contribute, actually read through the contributor docs? It turns out that it's not a lot. And a lot of people will just come in and look real quickly and say, oh, this is a simple change, I'll go make it. And so we have a fair number of early failures in the static analysis because of people who don't know the conventions. Once people do, that goes down a lot, and there aren't as many failures. When it comes to the regular CI testing, it's been failing quite a bit as we try to get on top of the tip of master testing. We've had long periods where it hasn't been passing, and we've been bugged by Aaron, who's sitting behind you, from SIG testing about getting it working, which we keep trying to do. Does that answer your question? Okay.
Hi, I'm Aaron from SIG testing. So I have an answer and a question. The answer for how you would get notified if your tests start failing in test grid is it can email you if they go from green to red. You just need to give it an email address. And this is something you could set up on a per dashboard, potentially per test case basis if you want the Jenkins chart maintainer to get nagged versus the Zookeeper chart maintainer to get nagged when that test case is failing. So totally happy to hook you up with that. The question is those early CI checks, is there any way I can run them locally? Like how would I do that just to make sure like everything looks good before I push it up in a PR?
Yeah, there's actually a repo that is totally empty on the Kubernetes Helm org for a project to do just that. That is on the to-do list that we haven't gotten to yet. But the intent is actually to have a tool you can run locally. We want to I'd like to containerize it so that way you can even run it within your own CI system against your own charts, right? If you're using Circle CI or Drone, which was demoed earlier, you could import that container and then use that as part of your process. That's one of the goals. Or you could run it locally as well. That's one of the hopes, and it is on the to-do list to try to make it easier across the board.
Since the last time I contributed a chart, have you added any ability to have value scenarios for your tests? So you can say, test it with this flag turned on, or test it with this flag turned off, as the user would actually do, and not just Helm install default chart?
No.
Is there plans to do that?
I think that's something we'd like to be able to do because it would let us do a few more complicated scenarios. I would say it's probably, with a bunch of the other things we've got going, it's not in the short term, but pull requests are welcome. And so if you want to come and help us do that, we'd be happy to talk to you about it.
Yeah, I was wondering, have you thought about the idea of just rotating through the entire library of stable charts and just giving everyone a periodic test just as a check to make sure that all of the charts still work with advancing Kubernetes versions?
Yeah, that's one of the things that would be really nice to do. We've got a whole bunch of stuff in front of that, but we have talked about that and doing periodic audits to try to make sure everything's still working. It's just a little bit further down the to-do list, but yes.
This guy. Are you running against master on Helm and Tiller too, or just against head on Kubernetes itself?
Just against the tip of master for Kubernetes. Right now, I think we're still on 2.7 for Helm. We haven't upgraded to 2.8. I went on vacation before 2.8.1 came out, and 2.8.0 had some issues.
Have you found any bugs in tip from testing charts?
Not since I have been dealing with this, but I've only been working on this for a number of months. Somebody like Vic has been doing it much, much longer, and he may know some of this. But not since I've been paying attention to it.
Last one on time. This is kind of teeing up your talk tomorrow, but you mentioned that of the top 100 contributors, not many are org members. I'm kind of curious why that would be, and like of the top 100 contributors, what would you say, like how many contributions are they making?
I would say the top ones have made a lot of contributions, some of them 100 or more. For many of them, in the top 100, it's more than 10 contributions. So it's not an insignificant number. A lot of those folks are people maybe at a company who don't do other Kubernetes things, right? But they're just contributing a chart for maybe their SaaS, like Datadog or something like that. And so this is just their touch point, and they haven't been interested or haven't so much, jumped at those opportunities. And so one of the things we are doing is, as we have introduced owners files, so that way some people can own it and merge things themselves and not worry about us, getting us maintainers in the loop. To do that, we are working to get more of them to be org maintainers and suggesting it to them and helping them on board, which we've done, I don't know, probably 10, 15 of them so far. And we're working to get more people into that position so that they are org members. But a lot of people, it's just, this is their only touch point to Kubernetes. And so they just haven't thought about it, aren't aware of our normal community norms or processes, because this is the only thing that they're paying attention to. Anybody else? All right, this is the last one, he says.
So beyond the normal newbie sort of errors, what type of things do you recommend to look out for that causes fails?
That's a good question. Besides the normal stuff that causes failures, yeah, test timeouts is probably it. We have test timeouts that are pretty long now, and we keep increasing them, but we've had problems with things that just take a really long time to start for the application. This has happened with a number of Java apps, which has actually caused us, we do have a timeout period where a lot of the Kubernetes infrastructure doesn't, and we keep having to increase that mostly for Java apps though, and stuff that's more complicated like stateful sets where it'll start something up and then you'll start getting the replicas up and those take a little bit of time. That's where we've run into more issues for things that just take a long time. And that is where we end up tweaking the infrastructure to handle it because we want to support more of those applications. Does that? Yeah. All right, I'll be around all day today and tomorrow. So if you want to talk more, you've got more questions, or you want to contribute to charts, come find me. Thanks, everyone.